Everybody needs to turn their audio off.
Oh, and we're live now to share it. Create post.
Okay, Mark, we right?
Nearly, give me 1 second. And we should be good to go.
You actually don't want to be.
Well, good evening, everyone who's joined us on Zoom and our Facebook pages. Welcome to the August monthly meeting. First, a few announcements before we get to our program. The first one is that after being approached by the Caulfield Racecourse Development Trust, the ASV has made an application to include the society in their redevelopment plans. Although it's early days, if successful, the ASV will have a new home, which will see for the first time all of its Melbourne-based activities at one site. That is our monthly meetings, our section meetings, our library, observatory, and outreach programs such as AFTP and public demonstrations.
And the library too, Steve.
Barry, I
No
meant
library.
library.
No library.
So more information will follow as we learn how our application has gone, but could be a very exciting time for the ASV in the near future. Second announcement I have is Vic South for this year, 2020, has been cancelled due to the Corona-19 virus restriction. So anyone who is looking at going to Vic South Star Party, it's been cancelled. All right, I have no more items of business. If I like to share my screen, I will do the new members now.
Yeah, can you take those out the oven, please?
Come on, this way.
Mark, can you hear me?
Yes, we can.
Okay, I just got a message saying that I've been muted, but you must have muted everyone else. Okay, we have 29 new members joined us up to this time over the last month. We are losing members, but we're actually gaining more members than we are actually losing, which is a very good sign considering the sad times that we are at the moment. So I'll scroll through the new members. If you're a new member and it's your first time to our Zoom meeting, welcome. Okay. So that was our list of new members. Again, welcome. We look forward to seeing you in person once the restrictions are over. Otherwise, until then, enjoy our magazine. You'll get a copy of our yearbook. There's Crux Extra to keep you entertained, and our Zoom meetings to our section meetings. So we look forward to seeing you at those forums. That brings us to our syllabus item, which is featuring two of our section directors giving a talk on their relevant areas. Who would like to go first? Ross, would you like to go first or would you like to go second? Mark?
Ross can go first.
Ross, you've been dobbed in. So are you ready to share your screen?
Yep, I'm ready to go. Yep. So
okay, Ross, well, if everyone else could mute themselves while the presentation is on, it'd be much appreciated. Okay, Ross, over to you.
Okay, this is sort of an introduction to what cosmology and astrophysics does. So it's based around a discussion group that meets monthly on the first Wednesday of the month to discuss current topics in cosmology and astrophysics. Discussions based on published material from scientific and astronomical sources, both paper and digital sources. We look generally at concepts rather than mathematics. About the most complicated formula we normally talk about is E equals MC squared or something like that. And of course, at the moment, everything's by Zoom.
我阻住你。係啊，彈開啊 ，go go go。
The topics come from generally from one of three basic ideas. First is looking at topics related to the origin and the evolution of the universe. Obviously, that includes things like the Big Bang, how it happened, how it evolved, and what came before. The early universe, the first stars, and so forth, and how the expansion has progressed over time. This includes things like the search for dark matter, working out what is dark energy. That's something that's totally new, and it's certainly a lot of thought gone into that lately. The second area is the formation and structure of things like stars. How they get created, how they evolve. Solar systems, how they're created, including our own. There's still a lot of work sort of thinking about how our solar system formed and why it's different to other solar systems. One area of great research at the moment is the Kuiper belt, and the Oort cloud hasn't been found yet, but the Kuiper belt certainly, and what impact this has on our solar system, or how it relates to the formation of our solar system. We look also at the formation and structure of galaxies, black holes and neutron stars, quasars, supernovae. And the other aspect is there life elsewhere in the universe? Is there life on? Is there intelligent life on other planets? And extrasolar planet research is one of the areas that's being considered. The Drake equation. This is where they're trying to predict the likelihood of finding life on another planet. Possible life in our solar system. There are a number of moons that have the possibility. The formation of an evolution of life on Earth, just how it got underway, and mass extinctions. There's been several mass extinctions where, the worst one is something like 90% of all species went extinct, but life bounced back very quickly. Last year we also held two presentations for cosmology and astrophysics for beginners. We also held one in this last July, and we got one coming up in September. And these are under the brand name of Cosmology and Astrophysics 101. Okay, so I'll just look at a bit deeper on some of the more popular topics. Gravitational waves. These are disturbances in space-time predicted by Einstein's general relativity. After an upgrade in 2016, there was a detection made of a binary black hole merger event. Since then, about 40 events have been detected. Most were binary black hole events, a few binary neutron star events, and I think one black hole neutron star event. This is one of the detectors. I think this is there's two detectors in America. One in Hanford, Washington State, and the other one in Livingston, Louisiana. There's also a detector in Italy called Virgo, and there's several others being built. I know one in Japan. This one I think is the Washington State one. I'm not sure off the top of my head. But it basically consists of two arms around about 4 kilometres long. This is one of the events. I think it's probably the first event. The top left-hand corner is the signal that came in Washington, and the one in the top right-hand corner is the signal that came in Louisiana in the blue, and you can see it superimposed over the there's a faint trace there from the comparative there, and then the two images below that are sort of the expected signal, and then the image below that is the error. You can see it's quite low. And if you look at the scale up beside there, the one there represents is 1 part in 10 to the 21. Extraordinary low movement. It's a depiction of what a binary black hole would look like just before collapsing and the waves given off by it. Okay, black holes. This is another prediction from Einstein's general relativity. It's a region where gravity is so strong that nothing, particles or electromagnetic radiation, can escape from it. For a given mass, a black hole is the densest possible object. First observed indirectly by the orbits of nearby stars. In 2017, the black hole in M87 was imaged by what they call the Event Horizon Telescope. And a recent paper shows that the black hole has a fuzzy event horizon. And this is something that Hawking predicted back in the 80s, and we've not been able to prove to date. To understand how black holes work, we need to understand how both quantum mechanics and relativity can be combined, and it's a major research area. This is the image. The dark section in the middle there. That part there is the black hole, and this is light being bent around there, going through the accretion disk. This is the telescopes involved in the Event Horizon Telescope. One of the main ones is Ulmer in Chile. There's also one down in the Antarctic, one across in Hawaii, and across in Europe and America. So there's eight different observatories involved, and some of them have quite a few dishes involved in it. For example, the Ulmer, I think got something like 60 dishes. Kuiper Belt and Planet 9. So there's more than 2,000 objects known to lie outside the orbit of Neptune. The Kuiper Belt was predicted by several astronomers in the 30s, 40s, and 50s. All except Pluto have been discovered since 1992. Pluto, as we were aware, was relegated to the Kuiper belt in 2006. And then in 2003, they discovered an object that lies outside the Kuiper belt called Sedna. This is a picture of the Kuiper belt. The blue are what they call the classical objects. This is Neptune, Uranus, Saturn, and Jupiter. The Sun in the middle, of course. So these are best pictures or typical pictures of what we see. And you can see Pluto's the only one we've got close to so far. The others are just small dots. But you can see several of them have got moons. Eris here and Maia's got a moon. Makamaka's got a moon as well. Pluto's got about 5 or 6 or something apparently. So, as I said, there's 12 objects that lie outside the Kuiper belt in highly elliptical, what they call detached orbits. And they're called detached orbits because their perihelion is outside the radius of the Kuiper belt. And because of that, they're unable to be scattered by Neptune. They're beyond the reach of Neptune. Predicted in 2014 was what's called an object called Planet 9, which is supposed to be larger than Neptune. This is a picture of Sedna. You can see just a faint dot. This shows the orbit of these of the objects out there. You'll notice most of them lie on one side of the Sun. Only one object here is on the other side. The likelihood that this was a random event is probably higher than the winning tats. The explanation that Mike Brown's team came up with is that there's a planet on this red orbit here called Planet 9, which has caused these objects to move across or get scattered across to the other side of the Sun. Exoplanets, first confirmed detection was in 1992. Something like more than 4,000 have been confirmed. They've also made the conclusion that all stars are now believed to have planets. They're also found in binary systems. The next challenge is to detect life on an exoplanet by using a spectroscope. This, of course, probably won't happen till they get some of these 30-metre telescopes up and going. In a binary system, there's two possibilities. What's called an S-type orbit, where you've got a large distance binary system, and planets can form around one of the stars or both of the stars. There's several hundred systems that are known with this S-type configuration. This is also called circumstellar orbit. There are systems where there are at least one or two systems where there is planets going around both stars in that scenario. The other arrangements are called a P-type orbit or a circumbinary orbit, and that's where you've got a close binary system and you've got planets going around both stars. This is much rarer. There's something like 13 or 14 of these known. Okay, so in the dark matter, in the 1930s, observation of the motion of stars and galaxies led to the proposal of dark matter. The observation of motions of galaxies and their distribution also imply the existence of dark matter. This is a typical curve for a galaxy, is showing the actual These yellow and blue points here are the actual observations. This is sort of a smooth curve, but based on the visible light, this is the expected rotation. You can see there that the object, the gas in the distance is rotating much faster than one would expect based on the visible light in the galaxy. Ordinary dark matter can only explain. Ordinary dark matter is things like planets and gas. Ordinary dark matter can only explain a small percentage of the predicted dark matter. What's called non-baryonic dark matter is proposed, which interacts with ordinary matter and not the electromagnetic force. In other words, hence it's called light. Sorry, dark, because it doesn't interact with light. Experiments to detect non-baryonic dark matter have not resulted in findings which have been accepted. There are a few people who think they've found something, but there's no agreement on their results as yet. Modified Newtonian dynamics was proposed in 1982, and it's for very small gravitational fields. In other words, a billionth of what we experience on Earth. Newton's law has never been tested at gravitational fields this week. It's very hard to do a test when we've got 1g gravity. This is the blue line represents Newton's force of gravity. You can see on a log scale, it's a straight line. The green line represents modified Newtonian dynamics, and you can see that it weakens at very low gravitational fields, and by this means it's supposed to replace a lot of the dark matter. There is a very strong debate going on between those who favour dark matter that they can't find and those who think MON can answer most of the questions. Dark energy, discovered in 1998. When it was some work done where a distant supernova were fainter than expected, led to the conclusion that the expansion of the universe was accelerating. This was said to be dark energy. As yet, we don't know what dark energy is. These are the Nobel laureates who led the teams: Brian Schmidt from Canberra, Adam Rees and Sel Perlmutter, both from the United States. The effect of that is, for example, we've got the Big Bang here. You get rapid expansion immediately after the Big Bang. The universe starts to slow down, and then for some reason, about somewhere between 6 and 8 billion years after the Big Bang, the universe suddenly starts accelerating again. At the moment, the 73% of the universe is supposed to be dark energy, 23 unknown dark matter, 3.6 known dark matter, and 0.4% luminous matter. So in other words, 96% of the universe, we don't know what it is. Okay, thank you for your attention, and hope to see you at the next meeting.
Okay, thank you, Ross. Are you willing to take a few questions?
Oh, sure, yeah.
I've got one first.
Yep.
You mentioned that LIGO is actually detecting rotating interactions between black holes, double neutron stars and whatever. How do they tell the difference between one, whether it's two neutron stars or two black holes?
One of the things they try and do is calculate what the masses of everything is, and I'm not sure exactly how they determine that. But certainly the difference in the masses is a big giveaway. There is also differences in how the other signals happen as well. Sometimes they can work out what actually collided before. In other words, they've got observational evidence of it before they saw the collision. Actually, recently, one of them they worked out exactly where it was, and they were able to show that that one of Einstein's predictions had never been shown before, and that was that the speed of gravity is effectively equal to the speed of light by measuring the time when they received the gravitational waves, and the time that they received the signals from on other telescopes.
Okay, any other questions? If you have them, just unmute and ask them. Okay, if there's no other questions, we'll move on to our next speaker, which is Mark, who's speaking on the deep sky section. If Mark is brief, we'll have time to actually show you a little bit of the Caulfield Racecourse Redevelopment Trust program at the end after Sky for the Night. So you might want to stay around and look into that one. So Mark, if you'd like to take over and give your presentation, please.
Certainly can. I'll just get myself ready. Now we look in. All right. Can we all see that? I'm assuming we can all see that.
Yes.
Yep, cool. Okay. So my talk on behalf of Paul, our Deep Sky Section Director, is not as detailed as Ross's talk is, because we're not as detailed a bunch of blokes and ladies and kids when we do our deep sky stuff. We like to get up to the LMDSS and get the 40-inch and 25-inch and have a look around at what we can see in the night sky if we've got clear skies. So our lovely tagline, in a galaxy far, far away, and our little secret little hashtag, get lost in the universe. So I'm going to give you a bit of a run through of what Deep Sky does when we have our section meetings. So Deep Sky, it's essentially just about gathering as a group to observe the night sky. It doesn't matter whether you're a beginner or an expert in astronomy. When I started with the ASV, I had no idea about telescopes. And now I'm 87% trained on the 40-inch, so Paul tells me, and trained on the 25-inch as well. So it can be done. You can be a novice like I am and learn how to use the equipment the ASV's got and come up and join us at Deep Sky. We meet once a month on the weekend nearest to the new moon. Any ASV member can come along to Deep Sky section. We don't restrict it to non-deep sky people. We even allow astrophotographers to join us every now and then. So we have access to the 25-inch and 40-inch. We also have access to an 18-inch, as well as a lovely pair of binoculars that members can use. We have some other telescopes up at the site that you can use as well, and you can bring your own equipment up, obviously. And the aim is to provide novice astronomers with the ability to learn from experienced observers. So I've learned everything I know from Paul and from Noel as well. Paul Gardner, the Deep Sky Section Director, and Noel Harvey, who's the Bendigo Section Director. They've taught me a lot. A lot of other members of the ASV have taught me a lot as well. And they've taught me, and they'll teach you what eyepieces you should use, what filters work best, and what resources will get you the most out of your observing experience. And for the seasoned observer, the Deep Sky section provides an arena to get together, share information and experiences, and impart knowledge to astronomers new to the field. But most importantly, it's about having a great time. And Paul will agree that it's about the warm donuts at snack time late in the evening. So that's another thing we do. Late in the evening, we will go up to the club rooms and we'll sit around and have a chat about what we've looked at, what we want to look at, what's happening in astronomy at the time, and just a general catch up. It's a very friendly environment, and we like to have as many of you come along and join us as we can, because we've got some access to some wonderful, wonderful equipment. So we observe, when we're doing it, we observe galaxies, open clusters, globular clusters, planetary nebulae, mission nebulae, reflection nebulae, and dark nebulae, just to name a few. So as I said, we've got access to the 25-inch and the 40-inch, and the 40-inch we can view objects out to about Mag 18, which is pretty impressive. It's a pretty impressive kit, that's for sure. We also have a Messier 100 club for anyone willing to do it. There's a downloadable PDF on the ASV Deep Sky section webpage for members. So all of the objects are visible through 4-inch telescopes under dark skies. Many of the objects can be seen with binoculars, and some of them can be seen with naked eye. The Vic South Desert Spring Star Party, which we've heard tonight has been postponed this year or cancelled for this year, is a good opportunity to see the objects that us Melburnians can't really see, objects like M51, M63 and M76. And the aim of the Messier 100 Club is to observe the objects through manually run telescopes. So no cheating, not allowed to use electronic gear. Try and get you to do it manually so you can learn the night sky. And this way it teaches you to star hop your way through the night sky and learn the constellations. Now, some of the objects, these are a couple of the objects. Obviously, they don't look like this through a telescope, and objects may appear further away than they actually are. Sorry, may appear closer than they actually are. But these are some of the objects: Messier 1, Messier 20, Trifid Nebula, Messier 33, we've got M42, which is Orion, M57, which seems to have been a hit on our public Facebook page recently, and M104, the Sombrero Galaxy. So it's just a couple of the objects that we'll look at. Obviously, these are astrophotography images, and all of these images are images that I've come across, except for M1. All of the other images are images that were taken by ASV members. So at the moment, obviously with COVID, the LNDSS is shut down, so we're running via Zoom. So all our meetings are on Zoom at the moment, which means every ASV member can come along to our section meeting, join in on the monthly meeting. We essentially do the same thing. We live stream objects. Recently, we've been able to use Noel Harvey's equipment up in Bendigo, and we live stream from his backyard. We pick objects from a list in the sky, and we'll move between them using his astrophotography equipment, taking 1 to 2 minute exposures and sharing them on the screen for everybody to see. It's quite an amazing way to do astronomy from home. We also have a monthly object list by Deep Sky members. This month will be Steve Thurm has put together a list for the Deep Sky team, and he's going to run a presentation on that for us. You can do it from the comfort of home as well at the moment, which is great. So you don't have to go out in the cold. And even if it's raining outside and we can't view objects live streamed, we still talk about what's on the lists, have a catch up, have a chat. And if there is a break in the sky, we'll try and hook some equipment up and have a look. All the ASV members are welcome, and the observing lists are made available after the meeting. So if you're not already an ASV member, join today. And our next Zoom meeting is Saturday, August 22nd from 8 p.m. And we welcome all of our current members and anyone who would like to join the ASV to come along to that meeting. And that's my short presentation on behalf of Paul Gardner for Deep Sky.
Okay, thank you for that. I want to point out to members that we have other instruments that can be used for visual use. We have a 12-inch Dobsonian along with an 8-inch Dobsonian where members do not require training to operate. So you can just go up on a dark sky night and get access to those instruments and just enjoy yourself. Whereas the 25-inch and the 40-inch, before you can actually use it yourself or by yourself, you have to have training. So if you don't want to wait in a line of people on the 25 or the 40 inch, you're more than welcome to just have a bit of a play around on the smaller instruments, and we're getting more and more of those as the time goes by. Do we have any questions that you would like to ask Mark on deep sky observing? No?
I
Excellent.
don't think anybody's got questions for me.
Okay. This is good because that means we can actually give the presentation of the racecourse redevelopment at the end. So, Perry, you're looking there like you're at ease and ready. Are you ready to give Sky for the month?
Pretty much, Steve. Thank you. I will share my screen. Good evening, everybody. Hope everyone is staying safe and well during this COVID lockdown period. And hopefully, if everybody does the right thing, we'll be out of it sooner rather than later. Just before I do get going, this is a fine bit of kit. Steve used to be an editor of it. I'm sure he will vouch for it. Current editor.
Absolutely.
Thanks, Steve. And if we look at page 81 of the ASV yearbook, don't know if you can read that. Can you read what it says? Anybody? Mark, can you read it?
Are you sharing this? It says, oh, hang on. It's a bit bent there, Perry. I can't quite read it. You might want to read it out for us.
Okay.
Visual meteor showers.
Yes, visual meteor showers that are being...
Not the ones that are happening now, that's for sure.
Well, one of them is happening right now because when I look down at the list, it says Perseids. The peak is the morning of August the 13th, which is tomorrow morning. And it says a ZHR, which is the zenithal hourly rate, meaning under the best possible conditions, you will get to see 150 meteors per hour. Take no notice of that, because for us in the southern hemisphere, the radiant of this particular meteor shower doesn't even rise over our northern horizon. So the ZHR, the zenithal hourly rate, is for somebody in a mid-northern latitude or a high northern latitude in the northern hemisphere under the best possible observing conditions. So no matter what you see on Facebook, on Twitter, on Instagram, in the news, in the television, don't get up tomorrow morning to look at these. You will just be wasting your beauty sleep. And as you can tell by looking at me, I have done that over the years. That's why I'm here to tell you not to do it, because I have gotten up for the Perseids and it's been just a total waste of time. I have not even seen one of these suckers. Do you think I made that point strongly enough, Steve, or should I?
They actually expect a better display this year than on other years. And if you do get out to a dark sky site, which is near impossible for Melburnians at the moment because you can't leave, but if you are out at a dark sky site, you may see the odd meteor trail coming out from the Perseus area. You can see Perseus from the LMDSS, just the bottom bit of it, but Perry's absolutely correct. You can't see the radiant point, but it doesn't mean you may not get a few sneaking up over the horizon so that we could actually get a glimpse of them. but not from your location, Perry, south of the city.
Or from Heathcote, Steve. I've had no luck anywhere I've gone. Just doesn't happen. So my advice is don't worry about this one. However, if you do want to see some meteors over the next few months to the end of the year, really there's perhaps 3 meteor showers worth pursuing for newbies that aren't particularly die-hard meteor observers, and they would be the Eta Aquarids in early May, the Orionids around the 20th of October, and the Geminids around Starbecue time in December. But all the others, you would have to be very desperate.
Except, Perry, the Leonids, when it actually gets at high activity.
Yes, although that hasn't happened for many years, Steve. Did you see the
early 2001?
Yeah. That was one of the best things I've ever seen in astronomy. It was fantastic. I think one of the best 3 things I've ever seen, if I don't count the time that I was in an elevator and the doors opened and Angelina Jolie walked in. But other than that, that's there. Any total solar eclipse worth going to. The Leonids, as I said, in 2001, and the other one would be Comet McNaught, perhaps the last great comet. Now, speaking of comets, I'm about to share my screen, and if you can't see it, please somebody tell me. Can you see it?
Yes.
Yep.
Good. Excellent.
Affirmative.
Great. So, Comet Neowise is finally in a spot where we can see it from the southern hemisphere. However, it's receding from the Earth, which means it's getting further and further away from us, so it's nowhere near as bright as what it was for those in the northern hemisphere. However, it's reasonably easy to find, but you will need, especially if you're observing from the city, you will need at least a 4-inch telescope or absolutely super red hot eyes for anything smaller, and try and find the spot away from light pollution, or at least any direct lights, as much as possible. Look towards the northwest. The sun sets around 5:40, so as it gets darker in the northwestern sky, or thereabouts, northern sky, Arcturus, bright first magnitude star, is what you should be looking for to begin with, because it's not far from Arcturus at the moment. By the way, Arcturus is probably the oldest thing that you will ever be able to see with your naked eye. This star is approximately 7 to 7.5 billion years old. There are no other stars that we can see with a naked eye that are as old as this. So it predates the solar system and the Earth. So while you're out there, make sure you look at it, because you won't see anything older. Not even Steve's older than that. So if we move on here, there's Arcturus, and as I said, first magnitude, you can't miss it. But these stars here, Murfred and Epsilon Boötis, can be your guides to finding the comet, because for tomorrow, it will be in a straight line with these guys right about there. So let's center it. And if you look for it, say around 7 p.m. Oh, now I need to, can I move this over? Okay. So let's zoom in, and there it is. This is not how it will appear in your telescope. This is being very, very optimistic and is more what you might have seen in the Northern Hemisphere. What you should look for is a soft haze, and that's about all you'll be able to see, especially from the city. But let's go to tomorrow's sky, because we can't see it tonight. But tomorrow around 7 p.m. or 7:15, it will be in a straight line. There's Arcturus again, there's Murfred and Epsilon Boötis, and in a straight line with those, there it is, and you will find it. But don't expect too much, and consider yourself very fortunate to have been able to see it, because the next time it will be around, none of us will be here. So, now, let's zoom out of there and let's go back to sunset tomorrow night, western sky. So we will be a little bit further over from Arcturus. And a bit higher up, let's see. Here we have the trapezoidal shape of Corvus the Crow, which is a little bit to the left of Spica in Virgo, or Spica, and some people say. And a couple of weeks ago, Crux Extra carried a piece I wrote on this particular star in the Double Star Diary. A star called Algorab, and sometimes also known as the Mercedes-Benz star. So let's move in here and see if we can split it. It's still well placed and easy to find. And there it is. There's two stars there. Algorab is magnitude 2.9, and the other is magnitude 9. So there's quite a bit of difference between them. But you should be able to see this with a smallish telescope. without too much trouble. So give it a go. You should be able to find Algorab at magnitude 2. You'll be able to find it from most of the suburbs, unless you're in the centre of the city, which will make it a little bit more difficult. The other thing I want to bring to your attention is in the south. So here we are in the southern sky, and currently at this time, you will notice that Canopus is about as low as it can get. So from our latitude in Melbourne, about 38 degrees south, it kind of skims the horizon. So if we zoom back a little bit in time, of course, here is the false cross, the diamond cross, and the southern cross are all in the southwest sky at the moment. And if we watch Canopus, then you will notice that a little bit after 9 or thereabouts tomorrow, it will skim along the bottom at due south. Now, have you noticed what happened there? If you've got any trees or anything else in the way or distant hills, you're not going to be able to see it. So if you can get, oh no, we've got a curfew, haven't we? Damn, well, it's not going to work. But if you can get on top of your roof and look straight down over the water, due south, you may be able to see Canopus do that. Or you may be able to do it later in the year once we're out of lockdown, but it can't be a lot later. Let's see, maybe, let's take the time back.
Perry, can I just put in a disclaimer? The ASV does not recommend that people climb the roofs at night. We take no responsibility for you doing that action.
Fair enough, we're not liable. Climb at your own responsibility, I suppose, or whatever, if you must. But
what I was thinking was peril.
Yes, peril is the word, you're right. But in September, around the 12th of September, maybe even later, we hopefully will be out of curfew by then, and you may be able to see Canopus slow down to the horizon at that time, which doesn't happen very often. Certainly, we don't take note of it very often, because in order to see it at its best, the ideal position is to be looking across the bay or from the peninsula across towards Tasmania over the sea there. And now,
just a question.
Sure.
What's that object moving between lower than the Magellanic Clouds, forming a triangle?
That one's Starlink.
Oh, well, get used to it.
Yes. There's a lot of Starlink satellites up there, unfortunately. Let's look at the eastern sky to finish off with. At soon after sunset, Jupiter holds pride of place right there. It's the brightest thing in the eastern sky, so that you can't really mistake it for anything else. And if we go back to tonight and we zoom in, through the course of the evening, you can see that it's spinning on its axis, and Io here, through the course of tonight, will go behind Jupiter and reappear on this side after a couple of hours. So let's watch it. It'll disappear about 9:40 and will reappear first in shadow. So let's zoom in a little bit more. Don't expect to see it come out from the limb because it'll be in shadow first up. There it is, but it's in shadow. The shadow, of course, belongs to Jupiter, and in a little while, it'll pop into sunlight and become visible to us. Now, tomorrow night, if we can zoom ahead one more night. Oops, sorry about that. Let's get over to the time. What we'll have tomorrow night is a transit of Io across, oh, damn. Let's go back a bit. Got the times wrong there. So there is Io about to transit Jupiter. There it is. And its shadow will be cast on to the upper atmosphere of Jupiter, or the upper clouds, and you can see the great red spot will be visible, although these days it's not so great. Maybe it's just the great mediocre spot. And it comes off the limb around 9:16 or 9:15. And sometime later, about 45 minutes later, the shadow is off the planet as well. That's something to look forward to tomorrow night or later this evening if you're keen to have a look at
Too many clouds, Harry.
I'm sorry?
Too many clouds tonight.
Is there? Okay.
Yeah.
Well, look, there are many opportunities to see these things. It doesn't mean that it's just tonight. You can check out the ASV yearbook, and that will give you more information as to when these events are occurring, or I'm sure there's apps that you can have a look at. But should it be clear tomorrow night, it'll be a good thing. And let's finish off, zoom out a little bit so you can see where we're looking. still high in the eastern sky, Jupiter, and there's Saturn. And if we zoom in on Saturn, the rings are very wide open at the moment, so pretty easy to see them. And there's some of the moons of Saturn as well. And if we advance the time, you can see those moons orbiting around this majestically ringed planet. So there's some of the things to look out for new observers and seasoned observers if you've not seen some of those objects before. So enjoy yourselves, because you can still look up at the universe after curfew from your backyard. Thank you for your attention.
Okay, thanks, Perry. We have one report from sections at the moment, and that is the library report. I'm going to put that on screen for you. No, I'm not. It's not that one. There it is. Oh, I've got to share it, don't I? Hang on. I'm going to share my screen. There it is there. Can you see that, Perry?
Yes.
Yeah. It's hard to read, but it's there.
Oh, Barry, get some glasses. Okay, so what we've got here is the library report. Barry, did you want to have a quick word? We've got time.
There's nothing to report. I assumed that Paul was going to make the presentation tonight and didn't realise Mark was. But, and we have an enormous number of books and DVDs on the areas of those two sections, cosmology and astrophysics and deep sky. In fact, I showed at one stage earlier a massive list of all the ones in the stars and things in the southern hemisphere. And I think another important, I'll just reinforce it again for those that don't realise. On the site tonight, and we could go to the ASV website, I think, couldn't we, Steve? And look and go down to the library and show what I'm talking about here. And that is that if you go to the library on the website, down to catalogue, roll down to catalogue, and then to categories, look at the category you want to look at, or type into a search for something you want to look at. Could be anything. If you want to type in quantum or quantum physics, you'll see about 34 items that have been added to the library since 1998 when I took over as librarian on quantum physics. Yeah, that's just let alone all the, we've got 37 great course sets of lectures in the library now. I only wish the library was open, we could show you them all. We can't.